Good morning, students. So we'll move on to the next example of parallel port. Okay. So in previous lecture, we were discussing about how parallel port used to work. Okay. What is the block diagram for the parallel port, and what are the circuit diagram involved for designing the parallel port? Okay. Later, we discussed regarding the generation of the status control. Okay, like SIN, how it would be generated using a flip flop and a latch. Okay, that we discussed in previous lecture. Fine. So today we will be discussing regarding a parallel port itself, but by taking an example of any output device. Fine. So in previous lecture, we discussed regarding an input device that was a keyboard. Fine. But now we need to discuss about printer. Fine. Which is a output device example. Fine. Now we need to identify what is the difference. Okay. The major difference we need to involve between the input device parallel port and the output device parallel port. Okay. So here you can easily observe we got total three different sections. First one we call it as a printer. Fine. So second is what the output interface. So this is what the port we are dependent on. Fine. Okay. And this is what the processor. Okay. So now we can observe like data address, read bar, write, master ready. It should be ready. Okay. Master ready, then slave ready. Fine. So these are the total components involved in the communication between the printer and the processor. Okay. Using parallel port. Okay. So we'll go through the working principle of this particular block diagram. So whenever the output device is idle or whenever it is free, okay, it will send an intimation to the processor that I'm idle. So if you are available with any information to be displayed, just send it. Right. So this is what we studied it from the first module and the first half of the second module also. Right. Okay. So now feel that printer is free right now. Okay. And he is ready to print the content. Okay. Pages. Fine. So what he will do is he will just send an intimation towards the interface circuit, output interface circuit. We are calling it as what? Idle. We are calling it as what? Idle. Okay. Whenever this printer is free or any output device is free, okay, then what they used to do? They used to send a signal towards the interface, output interface called as what? Idle. Okay. So by receiving this idle, see same kind of latch we are using here also, but the pictorial representation we don't have. Okay. So by using this idle signal as a input for that same flip flop and for the same latch, okay, we are able to generate a interrupt signal. We are calling it as what? S out exactly. Okay. So S out will be generated using that interface circuit. Okay. So now after generating S out is equal to 1, that will be communicated to the, observe it carefully, that will be communicated to the processor using the data line itself. Okay. Using the data line itself, again, we are going to send the S out signal towards the processor. Fine. Okay. So now idle signal we got from the printer inside the output interface circuit. Okay. We are using this idle signal as a input for the flip flop. Okay. Then it will be submitted for the latch. Finally, we are able to generate S out is equal to 1 exactly. Okay. So here also we are involving total 3 to 4 different types of inputs for this particular latch for generating S out signal 0 and 1 exactly. Fine. Okay. Remember, whenever we are getting a idle signal, then only S out will be set to 1. Okay. Such a kind of circuit we need to design over here. Clear? Okay. So now the S out is made as 1. Okay. So that will be intimated to the processor using a data line. Okay. So when the processor find that S out is equal to 1, okay, so what he will do, he will just upload the address of this particular device in the address line. First thing, remember, first thing, okay, address of this particular device will be uploaded. Okay, then what kind of operation should be performed, that will be uploaded in the control line. What, whether it is a read or write operation, it should be a write operation. Okay, processor is available with some information to be printed, remember. Okay, so the content is residing inside the processor, so that should be written inside data out register exactly. So what should be the command or what should be the control signal? Write should be the control signal over there. Okay. Meanwhile, observe it carefully. Meanwhile, we need to perform two different tasks. What is that? First, we need to generate master ready signal. Okay. Along with that, you need to upload the content which has to be printed inside the data line. Clear? So when SOut is set to 1, processor used to perform total 4 different tasks, very important tasks. First, the address of the device. Second, what kind of control. Okay, whether it is a read or write operation, that should be uploaded. Okay, later, simultaneously, okay, we are calling it as a simultaneously. Okay, master ready signal and data should be uploaded in the data line. Remember this. Okay, so now once all these 4 signals been generated, okay, all 4 will be reaching towards the output interface of a printer. Okay, so now what printer will do is it will enter the arbitration, sorry, not arbitration, address decoding phase. Okay, because address be uploaded by the processor. So when it find a match, okay, if address uploaded by the processor is 5 and if the address of this particular device is also 5, then there is a match, we are calling it as, right? Okay, then after getting a match, what your printer will do, okay, it will just go through what kind of uh, like control signal has been uploaded, that is what they write. Okay, it will not let this particular data to like come inside right now. What he will do, he will just raise a signal called as a slave ready. Okay, after identifying, okay, what is that particular device. Okay, if there is a match, he will just go through what is the command, okay, uploaded inside the control line. Later he will generate slave ready. Okay, when this slave ready signal get generated, then the content inside in the data line of a bus will start getting flow inside the data out exactly. Okay, we are not yet done. Remember, we are not yet done. So data will be available in the data out right now. Okay, observe it very carefully. Okay, then observe it very carefully. Then we can eliminate the master ready signal because slave ready signal has been generated already and data is also uploaded inside the data out. So master ready signal can be cancelled. Okay, and meanwhile, observe it. This data should be submitted for a printer along with a signal called as a valid. Along with a signal called as valid. Remember, why we are sending this signal called as a valid? Sometimes there may be a control signal which should be communicated to the processor, sorry, printer exactly. Okay, we want like it won't feel like whatever we are receiving from the data out or whatever we are receiving from the output interface, it should be printed. No, it is not the case. Okay, whenever we want to print the content, we need to send a signal called as a valid. Okay, if printer is receiving a data along with a valid signal, directly it will go for the printing section. Yeah, then the content will be printed continuously till it find the end of the page or end of the data. That's it. Okay, so this is how your parallel port output device used to work. Okay, so now we'll go through the entire circuit version for this particular concept. Okay, so the same kind we are having. So here we are having data out register. Okay, parallel ports we are using, right? So 8-bit parallel line we are using over here. Okay, if you want, we can go for 32-bit, we can go for 64-bit also. Okay, but here you'll be getting 32 different lines, 64 different lines over there. So because of that, for simplicity for the of the figure, we are just using total 8 bits itself. Okay, because of that 0 to 7 we got. Okay, so as I mentioned, like D0 we were utilizing it for sending S in signal in previous lecture, right? So S out will be sending through D0, D1 exactly. So using D1 we are transferring the S out signal. Now you may ask like how this S out will be generated. Okay, see here we are having a controller available over here. Fine. So observe it carefully. See, this is what a junction. Who is responsible for generating the S out signal, and he is also responsible for generating a valid signal also. Okay, valid in case of handovering the information to the printer. Okay, regarding that, we should generate a signal called as a valid. Okay, if printer is ready to print the content, he will be generating a signal called as a idle. That also be collected by this controller. Okay, and because of that, we will be generating S out signal exactly. Okay, so now we'll see or we'll go through the working principle of this particular figure. Okay, so printer is available here somewhere. Okay, he is right now available for printing the content. So you will just write the signal called as idle. Okay, so this controller receive these inputs. Okay, along with here 1, 2. Okay, see here 2 more inputs are available, 1, 2, and 3. Okay, by consuming total 3 different inputs, this controller will generate SOut signal is equal to 1. Okay, so that SOut signal will be transferred towards the processor using a line D1. Okay, so when line D1 is set to 1, okay, processor will identify which is that particular device who has raised this request. Okay, that SOut is equal to 1. Okay, after identifying that it is a printer, fine, he will just upload the address in the address line. So this is what the decoding section, okay, let it be. Then later, along with that, what kind of control signal should be transferred? Okay, that should be uploaded. See here, we are having a NOT gate, but in previous we didn't had a NOT gate, right? Okay, we feel that for write we are calling it as a 0, and for for read we are calling it as 0, and for write we are calling it as 1. Complement of that. Okay, complement of that we are considering over here. That's why R bar write complement we are considering. Okay, so now like write it is. So using this NOT gate, we can easily identify what kind of control signal it is. Okay, so now control will be uploaded. Okay, along with that, master ready signal should be uploaded. Meanwhile, data should be uploaded for this particular 8-bit parallel line available. Okay, so that will be uploaded in the data line exactly. Now, what your printer used to do is, he will just enter the address decoding phase. Okay, if there is a match, observe it very careful. If there is a match, he will just go through the control signal. What kind of control it is? It is a write. Okay, it is a write command exactly. Okay, after observing those two, fine. By utilizing, observe it very careful, by utilizing this read status and this load data location. So here it will be 0, here it will be 1. Here it will be 1, here it will be 0 exactly. Okay, still we are not done with, or we are not yet generated with the loading data operation over here. But we are at the phase of what? Reading the status exactly. Okay, OR gate we are using. If any one is any one point is equal to 1, okay, then easily we can generate slave ready over there. Okay, this will be like on off conditions here. If this become on, he will be off. If he become off, he will become on exactly. Okay, why we are just reading the status? See, sometimes there is a possibilities of lossage of data exactly. Fine, or maybe sometimes SOT signal may be generated. Okay, from this controls section. Okay, due to some error also. Okay, so that error will be not holding it for so long time. Okay, so before we start loading the content for the data out, okay, what we need to do, we need to just verify that whether this still that SOT signal is on or not. Okay, so for checking that, okay, this place will be set to 1. Okay, and this is still 0 exactly, right? So if you are setting this 1, or if you are trying to check this SOT is equal to 1, then obviously OR gate will be receiving 1 and 0, right? Because of that, okay, this OR gate will be generating a signal called as a 1. Okay, so now slave ready signal got generated. Okay, then later what we need to do, when the processor receive this slave ready signal, directly we are activating this module. We are loading the content towards the data out exactly. Okay, so now observe it. So this will become 0 and he will become 1 exactly. Okay, so data will be uploaded to data out register. Okay, from here it will be transferred towards the printer. Meanwhile, see, observe it very careful. Previously here we used to get 0, right? When he was 0, here also we were used to get 0 over here, right? Okay, but now observe it. When data transmission begin, the master ready signal we can eliminate, so he will become 0, but this location becomes 1 now. Okay, so 0 1 idle, still it is 1 exactly. So with all these 3 input, okay, it will change, remember. Okay, with these all the inputs, okay, your controller will generate a signal called as a valid. Okay, so data is available in the data out, valid signal got generated, then printer will start printing the content over. Clear? Okay, so same kind of working principle, but slightly change. Okay, the same thing explained in your textbook. Okay, so for notes, you just go through the explanation from the textbook. Okay, okay. So now we'll go to the next topic, that is serial port. Okay, very important topics. These are all fine, like parallel ports and serial ports exactly. Now, what does serial port stand for? Parallel port means like 8 different line we had, right, for data transmission, but here you'll be having only one. Okay, at a time we can transfer only 1 bits exactly. Okay, we call it as stuffing. Okay, we call it as 1 bit stuffing at a time. Okay, so we'll go through some technicalities of serial port, then we will go for a block diagram. Clear? A serial port is used to connect the processor to IO devices that requires transmission of 1 bit at a time. Okay, so the input device, output device, any devices, okay, those who are working based on a serial fashion, okay, remember our processor and our like internal circuits, whatever we are using in our laptop and computers are, they are working based on a parallel fashion, remember, okay. But due to the cost and due to the marketing competition, what the device manufacturers used to do is like a external keyboard, external mouse, okay, these are all different devices, printers and all. If they start designing it based on a parallel, there will be a slight hike in the cost. Okay, so for the competition sake, what they do, they will reduce the, like the motto is to reduce the cost exactly. Okay, the market price. Then what they do, they will be going for serial exactly. See, if you are using a serial for the data transmission, one line is enough, right? Okay, but there, how many lines you need to? Okay, you need to go through total 8 different lines over there. Okay, 7 lines will be more. Okay, so like this, it is just an example, like for the cost they are using for the serial and all. Okay, apart from that, there are a lot of changes they used to perform, okay, to minimize the cost exactly. But this will be one of the reason. Okay, so now like if you want to, if your device is working based on a serial fashion, then obviously your processor must start transferring or start communicating using serial fashion itself. But observe it very careful. Your processor or your system is working based on a parallel fashion, but your like devices are using serial fashion over there. There is a gap. Okay, there is a communication gap, right? Okay, we need to have some converter over there. We'll see this, what kind of converter we are having. Then later, key feature of serial port interface circuit is it is capable to communicate in a bit serial fashion on the device side. Very careful, observe it, bit serial fashion on the device side and in a bit parallel fashion on the bus side. This is very important. Okay, the serial port circuit, what I'm going to explain in the next slide. Okay, he is having a potential to communicate in a serial fashion in case of a device side. Device means what? Example, keyboard. Okay, example, keyboard. Or else, let me take an example of a printer itself. Okay, so printer, feel that, okay, he is working based on a serial fashion. Okay, but your processor or your system is working based on a parallel fashion, right? Okay, so we need to have a interface circuits, so like in case of device side, it should work as a serial fashion. In case of a processor side, it should, or else in case of a bus side, it should work as a parallel fashion. Okay, then we don't have any problem with conversion, right? Okay, we'll see this, what kind of converter we are using over there. The transformation between the parallel and serial fashion is achieved with shift registers. Okay, so this is what the main converter we are using over here. We call it as a shift registers. Okay, who is responsible for converting serial to parallel and parallel to serial. Okay, so now we'll go through the serial port block diagram. Okay, so observe it very careful. So in this figure, main thing you need to explain is regarding the shift register. Okay, regarding the shift register, very careful. Okay, where we have this shift register, see, this is what one shift register we are having and this is what another shift register we are having. Output shift register, input shift register. Okay, then later data in. Okay, then later data out you are having. Okay, these are the what the data lines. Okay, like in case of input, data will be sent to the processor. In case of output, data will be sent to the output device exactly. These are the way. Okay, remember these are the parallel fashion working. Observe it carefully. So these dots, okay, indicates what? Don't feel that we are having only 2 lines, or here we are having 0 to 7, total 8 lines we are having. This dot represents what? Here we are not naming like D0 to D7. Remember, okay, this indicates that total 8 different lines, parallel lines we have. Okay, shift register to data in to, see, this is what the junction exactly. Remember, this is what the junction, okay, which will allow us to transfer the information towards the processor and to fetch the information towards the output devices exactly. Okay, I will explain the working of this particular. Okay, so here serial input, serial output. Okay, these are the two varieties. Then status and control, we are connecting it for the data line itself. As usual, like status, if data in, like data is available in the data in, then the status will be utilized. Okay, using D7, we are transferring it for processor, like data is available in the data in. Same fashion, like data out, if your printer is ready to print the content, using the same line itself, using the same model status itself, we are communicating to the processor that yes, the output unit is free to display the content. Okay, by using S in and S out. Clear? And control signal also, okay, see D naught, okay, D naught, what kind of control, whether to read or whether to write, okay. So don't get confused. It is bit different, okay. In case of serial, the circuit diagram is bit different, but simple exactly, okay. We are not using any kind of a gates over here, okay. We don't have a different sections or different inputs available, okay. It's very simple, fine. And this is what the interrupt, fine, okay. Through which we can raise an interrupt request towards the processor exactly, okay, using status and control. Then receiving clock, transmission clock, we'll explain this what exactly. Then here chip and register select we are having. So here we are mentioning two register RS1 and RS0, okay. Then later my address, like particular address, if you are referring any like for the decoding section we are using read bar write control as usual, ready, okay. So this is what the ready, master ready. Remember, don't get confused. Master ready it is. Observe it very careful. Okay. It is a ready signal sending towards. Okay. Sending towards what? Input or output. Okay. See, whenever you are communicating with the input unit or output unit, first what you need to do, your processor should send master ready signal towards them. Okay. Then they will react with accept or slave ready exactly. But here for that slave ready, we are naming it as what? Accept. For master ready, we are naming it as what? Only ready. Clear? Okay. So all are having the same working principle how we discussed in the previous section. Now forget about this. This is very simple. Okay. Already we know about this. Very important thing is this section exactly. Okay. And these 2 points. Fine. So now, as I mentioned, feel that we are having a input unit over here and we are having a printer over here. Okay. So wait. Okay, let it be a keyboard and here it may be a printer exactly. So these are the 2 examples I would like to take. So feel that your keyboard is working using serial input fashion and your printer is also using serial output fashion exactly. Okay, like 1 bit at a time it used to print over here. Okay, so now if data is available or if user is printing the if your user is typing any sentence, okay, then that alphabet should be converted to a ASCII code. That ASCII code will be, observe it very careful, that ASCII code should be converted into a binary, and 1 bit at a time we are communicating towards the processor now because we are using a serial fashion over here. Okay, 1 bit at a time. See, if you are continuously uploading the information to the data in 1 bit at a time, it will be a hectic job. Seriously, I tell you. Okay, so what we do, we are using a one more buffer kind, okay, shift registered we are calling it as. What it used to do is, he will just collect, like it will be having around capacity over there. Feel that like here we are using total 8 different lines, right? So feel that we are having a capacity of 8 bit to store inside this shift register at a time. So like continuously he will be transferring 1 bit at a time, right? So once we reach 8 bit, so what this shift register will do is, he will just shift all that 8 bit content parallelly to the data in exactly. I repeat, this shift register will be collecting the 1 bit information from the serial input device at a time. Okay, so when we are reaching that 8 bit continuous, okay, 8 bit, when we are done with 8 bits, 8 bit will be shifted to data in exactly. Parallelly we are submitting. At a time, 8 bit will be submitted. Okay, so later, as usual, data in we got some information, then the status register will raise an interrupt request, okay, towards the processor. Okay, then processor will upload the control signal exactly, like we need to read the content, the device address will be uploaded. Okay, then ready signal will be generated. So once it has been received by the particular device, okay, so it will enter for the decoding section. If that is targeting for this particular data in exactly, okay, then what he will do, he will just generate accept phase, like slave ready signal, that is we are calling it as accept exactly. So after receiving that accept, for continuously data and content will be uploaded for the data line exactly, that will flow in this direction exactly. Fine, now the data will be transferred towards the processor exactly. Now observe it very careful, we are having something called as a receiving clock and a transmission clock. What is this receiving clock? See, 1 bit at a time, right? If you are receiving time of the bit, if it is less, okay, that can be traced and that can be tracked using a receiving clock over here. Okay, so here we are having some standard time duration for receiving those bits exactly. Okay, one by one we are receiving, right? Okay, like within 1 second, 16 bits should be received. So that if it is a benchmark. Okay, so we are comparing it with our receiving clock exactly. The receiving rate
will be compared with this receiving clock exactly. Okay, if both are equal, then no, okay, no problem. Okay, if it is reduced, okay, they like input rate from the device, if it is reduced when we are comparing it with the receiving clock, okay, then what we need to do, it should be intimated. See here, that's why we are having a control over here. That's why we are having control over here. Okay, so what we need to do, we need to make some alteration so that the receiving time or receiving bit should be speeded up. Okay, then later we are going to achieve the receiving clock over there. Fine, the time, okay, like that will be available, right? Like within 1 hour you need to reach some particular destination. Okay, if you are lagging, then we need to rise our speed. Okay, then easily we can achieve that, right? Like that. Okay, for that purpose we are using receiving clock over there. Then what about for the transmission clock? I will explain you later this. Okay, so now feel that now device output device printer is ready to print the content. Okay, so he'll be raising a request towards the like devices using this status section. Okay, then later the data which is to be printed, okay, so that will be uploaded in the data line. Okay, so here data is available right now, it is not been uploaded to the data out. Okay, when we are raising this slave ready, then only we can upload, remember. Okay, so now the address for this particular device will be uploaded. Okay, then later write command will be uploaded, then later ready signal will be uploaded. Okay, when we all these three signal will be received by this particular device, okay, what he will do, he will just go through the address decoding phase. Yes, he will find that yes, there is a match. Okay, then he will just raise a accept phase. Meanwhile, the data which is residing inside the data line will be keep on uploading for the data out exactly. Okay, so now when it is being uploaded to the data out, fine, now just observe what is happening over here. Data out is accepting based on what? Based on parallel fashion. Okay, so now feel that like total 8-bit being received by the data out. Okay, right now, so this 8-bit will be uploaded to the shift register, output shift register. Now what this shift register will do is, he will leave 1 bit at a time towards the printer. Okay, like out of 8, first bit, second bit, third bit, fourth bit, one by one it will leave. Okay, so now we need to observe like what is the transmission rate available over here. Okay, feel that like within 1 second total 32 bits should be transferred towards the printer. Okay, if we are not achieving that, okay, if you are lagging with this performance, okay, then what we need to do, we need to boost it. Okay, see, this clock will be a reference clock for us. Remember, okay, receiving clock and transmission clock. While receiving, if you are receiving 8-bit per second, okay, it's, if it is a the average or else a standard receiving capacity, then okay, fine. Like if you are receiving per second like 5 bits and all, then we need to boost it. Okay, for identifying that whether we are lagging or not, okay, we are using a receiving clock and transmission clock over here. Clear? So this is how your serial port used to work. Okay, in case of input, collect it, okay, submit parallelly. In case of output, collect it, submit serially, exactly. That's it. Okay, so this is what the serial port and parallel port student. Okay, so in next class, we'll be discussing about like bus, like USB, SCSI bus. Okay, it's bit a theory topic. I will let you know whether I need to go for a video session or should I upload the notes. Okay, because it's entirely theory topic. Okay, like procedure, steps and all. I will try to explain, fine, once in brief. Okay, later I will submit the notes. Okay, okay, students, this is it for now. Thank you.